So in the previous class, we discussed about important aspects of HDFS and also how the storing of file happens in HDFS. Now the question is, if you have stored the file in HDFS, don't you think you need to read that as well? Otherwise, why do I need to store the file? I need to read that. Any thoughts from anyone? How do you read the file from HDFS?
Through data node.
Through data node. Okay. Data node is where the file is there. Okay.
It calls for the name node.
Absolute. Okay. First and foremost thing is, thank you, Anna. Okay, thank you, both of you. Okay. So what you have to remember is there are two nodes. One is the name node and data node. Okay. Like if you recall, when you have a big file that is split into smaller blocks, okay, and that is spread across different data nodes. Okay. So hypothetically, this is how the data is stored across different data nodes. It is not necessary that data node 1 will have block 1 and block 2 only. It may have block 1 and block 7. Okay. Just for the simplicity, I have distributed the blocks like this. Okay. It is not necessary that it will be sequential. It is not necessary. It all depends on the space available and multiple other factors. Okay. This is how the data is stored. Now, very, very important thing is we have data node, we have name node. Now, let us say if somebody sends a read request, okay, let us say Parveen wants to read a file which is distributed. First and foremost thing is that read request will hit the name node first, because name node is where we have a metadata to which describes which file, which block is in which data node. Okay. So from there it will go to the data node, whichever the data node, here in this case data node 1, and it will read the content and it will relay back to the user. Okay, fine, right? It is very easy, right? So Anna, thanks for that. So user requests to read a file, then the file request goes to the name node where the data about the data is stored, and from there it will get to know where the data is stored. Then it will come to the data node and actual contents are read and that are passed on to the user. This is how reading a file happens in HDFS. Easy, right? There is no confusion here, right? Mutumila, any confusion? You got it, Mutumila? Anybody? Anybody has any confusion?
No, sir.
Clear. Okay. Wonderful then. So this is how we read a file. Now, if I ask you a question, does any of your lives are going very smooth without any challenges? Means I don't have any challenge at all. I mean, everything is smooth. Since I am born until now, everything is smooth. No obstacles. Is that the case?
Yeah, sir.
No, right? Everybody would have challenges. So even there is a challenges distributed storage and distributed processing. Okay. What can be the challenge in distributed storage? I mean, when I say challenges in distributed system, I'm talking about the HDFS only. What can be the challenges in distributed system? Anyone?
Sir, the data gets stored in the local clusters.
Local clusters, okay.
So to read the data from the clusters, the process is very long. And first we have to read the data, then process the data, then again we have to save the data in that system.
Okay, that may not be a major challenge. That's okay. See, because we want to distribute the data, that is how the data is distributed. Now the data is distributed, obviously we have to read it. Okay. I think while it may not be the same as regular systems where the data is at one place, but that may not be a major challenge. Okay.
Sir, what if the reading request gets into thousand and lakhs of numbers? Then that
I
might be
mean,
a challenge, I think.
no, actually, see, that is where name node comes into picture, right? Depending upon the request of the user, it will locate the name node first. From the name node, it will go to the data node. Okay. Obviously, the amount of data what we are dealing here is definitely more. Okay. Okay.
So do
And
you mean the storing of the data or finding the data?
both are fine. We know that we are storing a lot of, I mean, both. Basically, in a distributed system, what can be the challenge?
So
Okay.
finding the free space for storing the data,
Okay.
is that a challenge?
That is established as a part of the process. That may not be a major challenge.
So
So
process
the failure of the
Okay.
nodes.
Come again?
Failure of the
processing
nodes.
speed.
Failure of the nodes. Okay. So Vinith, you were saying something
Sir,
in the
processing speed, I think.
processing speed. Yes, it may be this one, but not a major thing. Okay. If you remember, you asked me a question. I said I'll answer that in the future classes. What was the question you asked me, Vinith, earlier?
What if a node goes down?
That is one of the important. Okay. So couple of challenges. We know there is a name node, there is a data node. Okay. What if the name node goes down? The next challenge is what if the data node goes down? I mean, it goes for a matash or katam. If it shuts down, it crashes, right? Those are the important challenges in a distributed storage. Okay. So those are the important. Now, there are a couple of aspects in the data node failure. Okay. Let's say we have a data node 1, data node 2, data node 3, data node 4. Now, Vinith, have you written a letter?
Yes, sir.
Which letter?
Sir, it's a clarification to my senior.
Okay. Clarification to your senior. I was referring to the which letter I was referring to, Vinith?
The letter Jaipal has written,
which is that?
it's a love letter, sir.
I was referring to leave letter. You always think like this way. Guys are like this, right? Okay, me, I am also like that. Jaipal is also like that, and also you are also like that. Guys are like. All the girls are very good, right? Girls are very happy. Okay. Now let us say, let us assume. I don't want to kind of disappoint our Jaipal. If you really look on Jaipal's face, there is a smile, broad smile. Okay. Assuming that he has written a letter of 1 GB. Okay. And that is distributed across these 4 systems. Okay. Now, within that, the data node 1, there are 2 blocks, right? So, first block has hello Anita. He'll say address Nita in the first block, and then he will continue to write the letter. Okay. Now, what if the first block gets corrupted? There is a possibility, right? Okay. So, we will not be able to get the file in entirety. Is it a problem or it is not a problem, Parveen?
It's a problem only, sir.
It's a problem only because we are not able to get the data in entirety. That's a problem, right? So it will not be able to read the data in entirety. And what if the whole data node crashes? Is it a problem?
It's a problem.
Problem
It's a
because
problem.
when we have a problem with the one block only, if the whole data node collapses, then the whole data is lost. Okay. Again, we'll not be able to get the data in entirety. Okay. So, in both the cases, there is a problem. So what would be the solution according to you, Anna?
So we had learned that data node will replicate.
Absolutely. Okay. So we already know about this. In case the data node fails, we already know the solution. Okay. The solution is replicate the data, right? Beneath replicating the data.
Yes,
What
sir.
we are doing is, what is replication here?
Making a copy.
Making a copy. That is a replication. Okay. So we have to define a replication factor. So what is the replication factor here, Parvin?
Maybe how many times we need to do the replication?
Absolutely. Bingo. So how many times you need to replicate? Okay. In Hadoop 3.4, it is 3. Default value is 3. Means if you have a data, let us say in this case, our Jaypal's love letter, okay, that will be replicated 3 times. Okay. So one very, very important thing is the replicated blocks will not be stored in the same location. It will be stored in a different location. Why is that? Why it will be stored in a different location?
It will store means everyone will crash, no?
If we store the replicated block also in the same data node, if the data node crashes, we'll not be able to recover. That is the reason. We'll store the replicas in different location as well. Okay. So one very, very important thing is the replica location are also stored in the name node. Why do we need to store the replica locations in the name node, Anna?
So is it because a name node can easily identify where the data is? So
Because see, whether you have a actual data, replicated data, you need to know where the data is stored, right? Isn't it? Otherwise, how will you locate the data? Okay. So even the replica locations are also stored in the name node. You got it right, Shabna? If you don't store
Yes, sir.
the locations in the name node, you will not be able to locate the data. Whether it is a replicated data or any data, you need to store the location in the name node. Okay. That is one important thing. Okay. So at a high level, in order to store the data, you should always maximize the redundancy and minimize the write bandwidth. What do I mean by that is, so let us say you have a 3 racks, rack 1, rack 2, rack 3, and assuming that they are in a different locations. Let us say Bangalore, San Francisco, London, and SF. Okay. Now, when you say maximize the redundancy means ideally these blocks should be saved in a very different locations. Why is that? It will help in case if there is any crash. But at the same time, when you store the data from have to make a replicas, there is a write bandwidth used. Okay. So if you store the data here, here, in here, there'll be a lot of bandwidth being used. How much of data we are storing here? Vinith, what is the amount of data?
128 MB.
I mean, total. I mean, 128 MB is the block size.
Okay, sir.
We are dealing with how much data here? Loads and loads of data, big
Yes,
data.
sir. Yeah. That
Lot of data. Okay. When you're dealing with a lot of data, writing from one place to another place takes a lot of time. That is the reason, in order to balance two things. One is maximizing the redundancy. You should store the data in such a way that redundancy is maximized in terms of location. Okay. And also you have to minimize the write bandwidth. Okay. In order to do that, the best optimal solution in this case is, instead of storing the blocks, replicated blocks in 3 different locations, what you can do is you can store 1 block in Bangalore, couple of blocks in London, but in a different racks. Okay, that is how you can maximize the redundancy and minimize the write bandwidth. Okay, so this is how they make a plan to store the replicated data, so that way, in case if the system crashes, they'll be able to use the replicated data. Okay, that is how you take care of the data node failure. Is it clear? Any questions here from anyone?
Sir, I understand the redundancy thing, and there is a little bit confusion in the bandwidth term.
Write bandwidth means, let us say, now, so you store the data here. Okay, the data on file here, right? Let us say one file. Okay, in order to replicate this file, this has to be copied to another system, right? In it,
Right, sir. Right, sir.
Right. Okay. This copying involves a, how does it copy? This involves a bandwidth. Bandwidth, when I say bandwidth means, let us say, if you have to copy a data from one place to another place, that requires a network bandwidth, right?
Okay, sir.
Okay, that is what I'm referring here. Because we are not talking about 1 GB, 2 GB. We are talking about potentially TBs and PBs of data. Okay, if you have to transfer or copy a data from one place to another place, that involves a bandwidth. That is what I'm talking about.
Okay, sir. Okay, sir.
Okay. Any other questions from anyone?
So the racks will be stored in different locations, no, sir?
See,
Rack 1, rack 2, rack 3 will be in
yes.
different that multiple nodes are available in each rack. So if we store the third third replication in the rack 3 means it requires a lot of bandwidth because of the different locations.
Correct.
We avoid that. We are storing the second replication, third replication in the same rack.
Same rack
but
in a different node.
location.
Correct. You are right. Okay. See, the idea is, since we are dealing with the large amount of data, you should balance between maximizing the redundancy and minimizing the write bandwidth. Okay. This I took the different locations. Maybe let us say, assuming that your company is only within India. Okay. Then the locations may be Bangalore, Mumbai, Delhi. Okay. Instead of Bangalore, London, San Francisco, it can be Bangalore, Mumbai, Delhi. Okay, like that. Okay. Or let us say you have your company presence or data centers only in Bangalore. Within Bangalore, different locations, like that. Getting me right, Parveen? You got it right?
Yes, sir.
The idea is, you should have your replicas in a different places. At the same time, you should not take too much of bandwidth, write bandwidth. Okay, that's the thing. Wonderful. Then we tackled one challenge. What was the challenge we just tackled, Anna? Which was that?
Failure of nodes, sir.
Failure of data node. Okay. Which is another challenge, Shabna. One is data node failure. The second one is name node failure, right, Shabna?
Yes, sir.
Okay. Are you with me? 100%?
Yes, yes.
100%. I want 200% of yours. Okay. Because if you are you thinking something? Do you have any questions, Shabna?
No, sir, no.
Gotcha.
I got the my doubt. I had doubts, but when Parveen explained, I got it
cleared up. Okay, cool. Very good. Okay, wonderful. Now, the second problem is, how do you handle the name node failure? What is name node, by the way, Tuminal? What is name node?
Master node, sir.
Master node, where we have metadata, we have directory structure.
Metadata.
Very good. Okay. So, if the name node fails, map location mapping is lost. So if the location mapping is lost, then the data is worthless without the name node. Let us say now, let us say Parveen is in Texas, right? Parveen makes a wonderful biryani. We already know that, right?
Yes.
Okay. So is it okay if I come to your place in
Yeah.
Dallas, Parveen? Okay.
Please
So
welcome, sir.
thank you. Now let us say, now in this case, Parveen is saying welcome. Okay. Now there are two scenarios here. In the first case, Parveen gives me her address. In the second case, Parveen doesn't give me her address. Okay. Now, if she gives me her address, is it easy for me to locate her? It is not easy.
Easy, sir.
It is easy. Assuming that Parveen doesn't give me address, I land in Dallas. Okay. I'll have to go knock every door. Hey, is it Parveen's place? Knock, knock. Okay. Then I'll go to the next, say knock, knock. Is Parveen's there? Okay. So maybe by the time I find Parveen's place, I would have become Buddha and I would have died. Same is the scenario here. Okay. The name node is the one which stores the mapping or address of the data. If this address is not there, the whole data is worthless. This is a much bigger problem than data node failure, right? What do you guys say? Right? So how do we tackle this? What is the solution for this?
Take the replica of name node, sir. Is it?
Yes, you are absolutely right. Okay.
Okay.
But it is done in a bit different way. Okay. I'll try to explain that to you guys. Okay. Try to follow. If you are able to follow, and you can ask me question also. If you are not at all following, don't worry. Okay. So in name node, by the way, is it say again a system in a cluster. There are two types of files. One is called FS image. The second one is edit. Okay. These are the two types of file in each of the name node. FS image is the snapshot of the complete file system at the startup. Means assuming that Parveen, Anna, Mutminal, three of them are using a same distributed system. Okay. Parveen, Anna, and Mutminal. Okay. So all three of them are using a same system. Okay. Now, yesterday evening, okay, for the sake of simplicity, let us say all of them are working in a same company. Okay. After they left, they would have modified some files, they would have updated some files. Okay. And the system, let us say its system has system 1 plus system 2, system 3. There are 3 systems in a distributed system. Okay. What are the state of this system when they left yesterday? When they come back in the morning, what are the state at which? That snapshot of a complete file system at the startup. When the next morning they come, what are the state of that system will be a system at the startup. You guys are able to follow it, right? Any confusion here, guys? You have done, Vinith. What they have done is they have worked on the different files, and that update is saved. Okay. When they come back next morning, what are the state? That is the state at the, that is nothing but a snapshot or a state.
The state has been saved in a snapshot, sir.
Snapshot. Okay. So when they come next morning, that is how it will be loaded. It will be loaded into the memory when they start working. So when they start working, they'll be updating the file, right? Let us say file 1 is being used by Parveen, file 2 is used by Anna, file 3 is used by Mutmilan. Okay. As and when they are updating the files, that file logs are updated in the edits. Okay. FS image has a updated snapshot. Edits will have the logs. As and when the edits are happening to the file, that is stored in the edits. Now, what happens is, in order for the system to work properly, these edits should be merged into FS image periodically. You guys are getting it, right? So, edits need to be merged into FS image periodically. Okay. So, because until and unless you are merging the edits to the FS image, you will not know the most recent snapshot, right? That is the reason this has to be merged periodically. So, what is happening is, this merging of edit to FS image is a bit of a costly affair, intensive, system intensive. But name node is busy in assigning the tasks to data nodes and taking the report from them. Name node is busy in that. So if it starts merging these two files, it may take more time, and there is a possibly a delay in the processing. So in order to avoid that, what they do is they have a secondary name node. Okay, we have name node and we have secondary name node. There are two nodes. This is one node, this is one node. What happens is, this secondary name node takes the responsibility of merging the edits with the FS image. So far so good. You guys are with me? Parveen, Anna, Malini, Muthuminlal, Vineet.
Yes,
Are you
sir.
guys with me? Okay. So we
Yes,
have
sir.
two files, edits and FS image. This secondary name node takes the responsibility of merging the edits with the FS image and periodically sending that to the name node. Okay, because name node is busy dealing with the data nodes. Okay, this whole process of merging the edits with the FS image and sending that to the name node is called as checkpointing. This checkpointing may be done either every 15 minutes or every 30 minutes based on the way you configure. Okay, so now if you really see, secondary name node always has the current state of files, because this is the one which is merging the edits with the FS image. Okay, it always has the current state of the file system. Right, Parveen? Are you following me?
Yeah.
Now, in case there is a failure of the name node fails, secondary name node takes over, and system will create another secondary name node. This will become a primary. System will help to create this another secondary name node, so that the same thing whatever this was using will start doing. Anna, you got it?
Yes, sir.
Okay. So if you don't follow at all, I mean, try to watch a video. If you have any question, please ask me now. I mean, if I'll be able to clarify that.
So then the processing time, which one we need? That is then, which is the actual data, name node or secondary name node? Because
name node,
secondary
always name node is the one which is most important. Okay, this is the one which is communicating with the data nodes, right? But merging of these two files is done by the secondary name node. Merging of these files. So when I say FS image, it is nothing but file 1 updated, right? File 2, some deletion happened. That kind of a snapshot I'm talking about. Okay. See, always the name node is the one which is talking to the data nodes. But merging of the edits. Edits means as and when you are editing, that will be copied to the FS image. FS image is a snapshot or how the system, how the file system looks at any point of time. You got it, Shabna? The work is processing, everything is go through name node only. Only in case of name node failure, secondary name node becomes the name node. Okay, got it, Shabna now?
So sir, after the editing in the name node, the data will update it in FS image, right?
Yes. See, basically, as and when the edits are happening, that need to be merged to FS image. That is done periodically, I told. After merging, when both the nodes are active, merging will be done by the secondary name node. It will push the FS image, updated FS image to name node periodically.
Okay, sir.
Periodically.
Okay.
Okay. This is called as checkpointing. It may happen every 15 minutes or 30 minutes or 1 hour, 2 hour, depending upon how you have set the frequency. Only in case of name node failure, secondary name node becomes the name node. And system will create the another secondary name node. Because if you don't have a name node and a secondary name node, there are two problems. One is merging of the files needs lot of bandwidth. That cannot be done by the primary name node. In case primary name node fails, we need to have a backup, right? For these two things, having a secondary name node is very, very important. Okay, this is how name node failure is tackled. This is how we overcome the name node failure. Okay, interesting, right, Vinit?
Yes, sir.
Right. So, did you guys get the answer to all of you? I think you had question. Vinit had a question, and I think even Shabna, Praveen also had a question. Did I answer both of your questions?
Yes, sir.
Okay. Yeah.
So the second node updates the name node in every 15 or 30 or
depending upon the frequency, what you have said.
Depending upon the frequency, that is called checkpoint, right?
Yes.
Exactly.
Basically, checkpointing is nothing but merging of the edit to the FS image, and then pushing this FS image to the name node. This whole periodically doing this is called as checkpointing. Okay. So, as I told earlier, you will not notice this on a daily basis. You may not really, this is happening everything under the cover. I mean, you will not see whether FS image is updated, whether the edit is updated. You will not see all these things. Conceptually, we need to know how the distributed storage works. Okay. Everything is concealed for you. On a daily basis, you will not worry about this. Okay. But you have to appreciate how the distributed storage and distributed processing works. This is kind of a fundamental. This is kind of a basic. That is the reason you are learning these things. Otherwise, on a daily basis, you will not really worry about this. This is taken care by the systems. Okay?
Okay, sir.
Wonderful. Parveen, Anna, Shabna, Muttamilan, Malini, Muskan, Jaipal. Any questions?
No, sir.
Wonderful then.
No, sir.
If there are no questions, we will wrap up the class for today. Thank you.